Hi, chemistry class. It's Mr. Duffy. Today's lesson, we're going to talk about the metric system. So let's go ahead and get started. The metric system is sometimes called the System International of Units, or the SI system for short. The SI system allows us to measure different quantities. So it has base units depending on what we want to measure. Like, for example, if we wanted to measure how long something was, we would use a meter. If we want to know how much something weighed, we'd use a gram. If we want to know how much time something takes, we'd use a second. Each of these quantities in the metric system has a physical standard for what it is. So a designed definition for what a meter is. That way, a meter is the same in one location, like in the United States, and in Europe. So again, each of those units has a physical standard for the unit. With the base units, then we can derive other units such as volume or density and so forth. So the base units allow us to find other quantities. So like I said, every unit has its own defined physical standard, such as, again, like a meter is defined as the path light travels in one, basically 300 millionth of a second. So again, if somebody's in the United States and measures a meter, that's the definition of what a meter is. And so a meter would be the same in another part of the world because light travels the same speed in different locations. It's always a constant. Derived units also, again, just take those base units and say, what is density, for example? Well, it's mass divided by volume. So you have the mass base unit divided by the volume base derived unit, and that gives you the density. So again, a way of using the quantities in the metric system. But what we're doing in our lesson today is using the metric system for its prefixes. So we have those base units, but the metric system also has prefixes to those base units. And we go from the right side of the metric system to the left side. Each prefix is 10 times greater than the one that's to the right of it. So for example, if I go from centi to milli, the prefix centi is 10 times larger than the prefix milli. So if I measure something that is 4.67 centimeters, but somebody wants me to record that answer in millimeters, I would just change the numerical value, but the quantity still stays the same. I'm using a different prefix, but it is still 4.67 centimeters is equal to 46.7 millimeters. Somebody else wants it in meters, well, then I would convert it as well, convert the number portion into 0.0467 meters. And if somebody else wanted it in decimeters, for example, I could do that as well, 0.467 decimeters. All of those are equivalent to 4.67 centimeters. They just have different prefixes on that base unit. So how do we convert those prefixes, and what again do those prefixes mean? Also, where can I find those prefixes? Well, if you were here on orientation day, you got a periodic table, and on the back of the handout is the prefixes. You can actually, right there, you'll never have to memorize the prefixes to the metric system, because they're always going to be, that scale is always going to be on your periodic table. So it's kind of nice. So using that periodic table, again, we can look through what those prefixes are. If we look at the smaller end of the metric system, we have deci means a tenth, centi means a hundredth, milli means a thousandth, micro means a millionth, nano means a billionth, and pico, which is, I don't have up here, but it's on your scale, means a trillionth. So again, we have each spot 10 times larger than the next, except for when you kind of get down here, and you might notice that they are 1,000 times different. So what that means is we have some spots in the metric system that do not have names. They are little marks on our chart, but those spots have no names, but they do hold a place. So they don't want to name every single location on the metrics prefixes scale. So once you get a little further off to the sides, they just name every 3 spots versus naming every single spot. But in the center portion of the metric system prefix scale, every spot is named. Okay, so let's go to the left side, to the larger prefixes. So in the larger prefixes, we have giga, meaning a billion, mega, meaning a million, kilo means 1,000, hecto is 100, and deca, which is the one that's abbreviated, is actually the only one that's kind of abbreviated with 2 letters, which is a little bit annoying, is 10. Tera is also a trillion. That one's not up here, but tera is also a trillion. So that is the larger end of the prefix. And again, we have spots on the scale, the metric prefix scale, that have no names. Okay, so that's what the prefixes mean in the metric system. And again, what they stand for. And each one, again, you go from the right side to the left side. The right one is 10 times larger than the one to the left. What that allows you to do, since there is a 10 times factor for each of these prefixes, is allows you to move the decimal place of the numerical quantity to the right or to the left, the number of places that you move on the prefix scale. So a great example is if I'm going from the base unit here to milli, I'm moving 1, 2, 3 spots to the right. And so I would move my decimal place in the number 3 spots to the right. Okay, so you just have to, again, if you move to the left, 5 spots, you move your decimal place 5 spots to the left. So let's do some practice with that. I have some example problems that I'm going to work through with you. And again, your worksheet will be very similar to this. So here we have 0.45 centimeters, and we're trying to go to millimeters. First, I would locate that on my metric prefix scale. Centi is here, and milli is here. And I'm going 1 spot to the right. So it's just 1 spot over to the right. And so what I'm going to do is actually I'm just going to move my decimal place 1 spot to the right. That allows me to convert 0.45 centimeters to 4.5 millimeters. They are the same measurement, just again in different units. Let's try another one. So here I'm going to go 567 millimeters, and I want to go to meters. First off, I'd locate those on the prefix scale. Milli is here, and meter is actually a base unit. So I'm going to go 1, 2, 3 spots to the base. Again, it says none. That would just, the base is a meter. A meter is a base unit. And so I'm going to go 3 spots to the left and move my decimal place 1, 2, 3 spots to the left. There is a decimal place after the number. So again, it's just taking it and moving it over to the side. So it's now 0.567 meters. Let's take a look at another one. This is a computer quantity of bytes. So we're taking 14,684 kilobytes and we're going to megabytes. This illustrates moving through some of those spots that do not have names. So I'm starting in kilo. Kilo's here, and I'm going to mega. I have to stop at those places that don't have names, but it's 3 spots to the left. So now I'm going to take my decimal place and move it 1, 2, 3 spots to the left. It becomes 14.684 megabytes. Now, the next problem illustrates one final thing you have to do with the metric system. So I'm just going to move 3 more spots over to giga. 1, 2, 3 more spots over to giga. Again, I have to stop those no-name spots. And so I'm going to take my decimal place and move it 6 spots to the left. 1, 2, 3, 4, 5, 6. 6 spots to the left. And when I have something that looks like that and there's no number in it, I have to put a 0. So my answer becomes 0.014684 gigabytes by, again, converting in the metric. Again, they're the same measurement, just in different units. So that is, again, how to do basic conversions in the metric system. Now, there is one more thing that's a little bit more advanced, would be, what if I'm given a number in scientific notation? Now, scientific notation is a great way to represent very, very large numbers or very, very small numbers by using a multiplication times 10 factor. So we have times 10 to the 23rd. So this number, again, is 4.5 with 4.5 with 22 zeros after it. It's a very, very large number. But if I want to convert in the metric system and not have to worry about the scientific notation part, the metric system allows me to do this by just changing the exponent. If I'm moving on my prefix scale to the right, I would just add to my exponent. Let's say I move 5 spots to the right, I would just add 23 plus 5 would be 28. If I move to the left, I would just subtract from the exponent. So again, let's say I move 5 spots to the left, I would subtract from that, and 23 minus 5 is 18. So that is an easy way to make conversions in scientific notation with the metric system. Here's 3 examples on this. I've got 4.8 times 10 to the 5th milligrams, and I'm going to grams. Milli is here, and grams is a base unit, so I'm moving 1, 2, 3 spots to the left. What I'm going to do then is basically, again, subtract 3. If I go to the left, I subtract. So 4.8 times 10, that becomes 10 to the 2nd grams. Okay, so again, just subtract from that exponent. Next one we've got is 7.9 times 10 to the 16th kiloliters. So we're starting at kilo, and we're going to liters, which is a base unit again. Moving 1, 2, 3 spots to the right. And so I'm going to add 3 to my prefix, or to my exponent. 7.9 times 10 to the negative 13th then. Okay? So again, just adding to my exponent. Last one, I'm going kilometers to, that's wrong. It can't go to decigrams, so that's got to be decimeters. That was a, typo. Can't change base units, you can't change your base. But okay, so again, I'm going from kilo to deci. Kilo is here, I'm starting here. 1, 2, 3, 4 spots. I'm moving 4 spots to the right. So if I'm moving to the right, I add 4, and it becomes 2.9 times 10 to the 22nd decimeters. Okay, so that's the end of our metric system conversions lesson. Hopefully that kind of makes sense. Hopefully now you know how to convert the prefixes. And also, if the numbers are in scientific notation, you understand how to add or subtract from the number to make the conversions when you're in scientific notation. So, hope that helps.